Hi, hello, vanakkam, and welcome back to yet another episode on your favorite Little Slaw YouTube channel. So today in this video, we are going to look about a performance engineering related topic in which this was again kind of an interview question. So in which the interviewer had asked like, how would you choose to go with horizontal scaling or vertical scaling in your cloud to improve the performance? So nowadays we all know that the infrastructure is moving more into the cloud, and most of the questions were again are related to the cloud. And we were seeing a lot of people, a lot of interviewers asking questions related to cloud, and they are mostly in terms of the performance engineering related topics. So in this video, we will see about two topics. One is so basically the question is like how would you choose in terms of horizontal scaling or vertical scaling. So we'll see what are all the choices, or why should we choose vertical scaling, or why should we choose the horizontal scaling, and I'll go with the summary finally, so like which one should be chosen on which scenario, right? So basically choosing between horizontal and vertical scaling depends on various factors, and that can include the application's architecture, the type of workload, the desired performance. That's the main thing. The performance is the main thing, and then the cost considerations. Again, cost, the budget is again a critical part, and the potential for the future growth. So we will see what is vertical scaling is all about, and when to choose vertical scaling. So mainly when talking about vertical scaling, it is scaling up. So when we say scaling up, so vertical scaling involves adding more power to your system, to your existing machine, which is adding more power. I mean, it is adding more CPU, or it's adding more RAM, or it's adding more storage, or adding all these three. So when it is vertical scaling, it is scaling up. Right. So, firstly, okay, before we move on to this video, this is going to be more interesting. I know, and this will be like more beneficial for you. And if you are someone who is preparing for interview, or if you are someone who is working on performance engineering related topics or tasks, this will definitely help you to give more suggestions to your team. And yeah, before we move on, this is me, Asan Shanmugam. I welcome you all to our Little Slaw YouTube channel. Please don't forget to subscribe to our channel. Give a thumbs up if you like this video. Share the video with your friends who are looking for performance engineering related topics. And yeah, so now let's go to the video. So firstly, let me pick the first one, which is when to choose vertical scaling. So the first part is simplicity. So if the application is simpler, and if it does not require complex distributed system management, vertical scaling, which is scaling up, is often easier, and also it's quicker to implement, which is you can increase the CPU, the power, the CPU, the power of the CPU or the RAM or the storage. Because since we all know the application is very simpler, and it does not require any complex distributed system management, so it's often very easy to do the vertical scaling, and also, like I said, it's very quicker to implement. And at what scenarios are they suitable for? So it is suitable for legacy applications that are not designed to run on multiple servers. So since they were not designed to run on multiple servers, we can use the same servers, but we can use more power in terms of increasing its to increase its performance, right? And now moving on to the second part. So the second part is immediate performance boost. So an application needs a quick boost in terms of its performance. So by adding more resources to the existing server, we can provide an immediate improvement, right? Because we are adding the CPU, or we are adding the RAM or the storage, and just a quick restart will add more resources to the existing server, and in turn it quickly boosts the performance. And it's ideal for single threaded application where increasing the CPU speed or by adding more RAM will directly improve their performance. So that is the reason we are using the vertical scaling to scale up the load, or scale up the performance of the application. And now the third part. So the third part is limited budget. So initially it might be cheaper to upgrade an existing server than to invest in multiple new servers. So that is another main reason why we are going for vertical scaling, which is scaling up. So it is cheaper to upgrade a CPU or a RAM or a storage rather than investing in multiple new servers, right? And then moving on to the fourth reason, or the fourth step, is the database scaling. So databases that are of difficult to partition or shard can often benefit from vertical scaling until a certain point, because if you are distributing the database into multiple servers, then you might need to take care of the database, like how do they interact, or what kind of I mean, like when you're like start distributing it, you might automatically have to mitigate that risk, right? But when you're scaling up, you do not need to worry about the partition part, because they automatically will be taken care. But again, it's until a certain point. So that is about within the in terms of the database scaling. So if you're going to scale up database, yeah, you can increase its power up to a certain limit to increase the performance. And now moving on to the last part for this challenges. So when it comes to the challenges, there is always a physical limit to how much a single system or a single machine can be scaled, because that's the maximum capacity any system can handle. And also it can lead to a single point of failure. So if there is a failure, then yeah, so it definitely automatically will bring down, and yeah, so this can lead to a single point of failure. So that is all about the vertical scaling. So now we'll move on to the horizontal scaling. So previously we saw about what is a vertical scaling, and we saw about what are all the reasons to choose vertical scaling, and then finally we ended up with the challenges. So now in this video, in this section of video, we're going to see what is horizontal scaling, which is mainly scaling out. So horizontal scaling involves adding more machines or nodes to a system, distributing the load across multiple servers. So just to reiterate, in vertical scaling, we used to add more CPU or RAM, but for horizontal scaling, it's so simple. We're going to add more machines or nodes to the system. So that's the major difference between the vertical and horizontal scaling. So now by this time you might have got an idea like how what I mean how does the vertical scaling works, which is scaling up, and how does the horizontal scaling, which is scaling out, so which is you're going to add more machines, you're going to add more nodes to the system, which basically by distributing the load across multiple servers. So the first reason like when to choose horizontal scaling is high availability and redundancy. So if the application requires high availability and redundancy, horizontal scaling is preferable because it spreads the load and reduces the risk of a single point of failure. So that is the reason we go for horizontal scaling, because the reason here is the application will be redundant. So if some point of the system fails, the other point will help or will be available for the users. And again, since it is like some point of the time, like at least one of the scaling sets or the nodes or the machines are available, it will be like highly available, right? So the main reason is like if your application like needs to be highly available, like people nowadays want 100% availability, which is not at all possible, but still people wants to have like that, and then redundant, like if some uh, point of the machines, as if some point of the centers data centers do fail, then they really need to have the other support, like they need to be like supported by other systems, right? So that's the reason we are going for the horizontal scaling through high availability and redundancy, and it is essential for mission critical applications where uptime is very critical. So these are the reasons where we are choosing the horizontal scaling. And moving on to the second one, the second reason to choose horizontal scaling is scalability needs. So applications expected to grow significantly in terms of user base or data volume can benefit from horizontal scaling. And the reason, yeah, we all know any application or any business will automatically their goal is to grow significantly, right? In every year. So in those scenarios, they will have to scale their system since the users are getting scaled out. The data volume is getting scaled out. So automatically they also want to scale out their machine. So in that reasons, they need to bring out the horizontal scaling. And this horizontal scaling is suitable for web applications and services where user demand can increase unpredictably. Yeah, we all know there are like several scenarios for this particular reason. Like there will be user demand that increases unpredictably. Like for example, uh, if a business is like launching a new product, for example, if iPhone is launching their new product, we all know there will be like a lot of user demand. People will be logging into the system. They'll be booking their pre-book their phones, pre-book their iPads, pre-book their MacBook, whatever, whatnot. So in those scenarios, the scalability is handled by horizontal scaling, right? And then the third one, which is distributed workloads. So applications that can naturally split workloads such as web servers, the application servers and distributed database servers are well suited for horizontal scaling because we can add the systems and then just by configuring the connection, yes, we are done. So we can naturally split the workloads. If you want to add another machine for web server or for an app server or for distributed databases, yes, we can add a machine instead of adding more power. Adding another machine is more easy and we can split the workloads, right? And then the system designed using microservices architecture are inherently benefit from horizontal scaling. And yes, so the more the microservices started to grow, the reason or the horizontal scaling has also been increased drastically because it's very easy. Like the moment you build a new microservice, automatically you can add another horizontal a machine to the horizontal scaling, and then you can connect it, and automatically they start to communicate, right? So there is no need of making or any tweaking to the existing system, right? So that is another reason where we are selecting distributed workloads. And then the last reason, which is cost considerations over time. So although initially more expensive, yes, bringing a machine, maintaining it, patching it, having a person for maintenance and paying if it is in cloud, we have to pay for the machine. Yes, it's more expensive, but horizontal scaling can be more cost effective in the long run because it allows for incremental growth. And then cloud environments often provide easy horizontal scaling options. That is, you can add more and more instances. So that is about the cost considerations. And the final part, which is the challenges. So we all know, so these were the benefits, but still there are like several challenges as well, right? So the more complex to implement and manage due to the need for load balancing, the data distribution, and potential changes in application architecture. Yes. So the more and more we add, the more and more we are implementing and managing, there are chances are there will be a need for load balancing. Yes, you have to properly load balance them, you have to properly distribute the data, and also there are like potential changes in application architecture. Yes, the more and more you keep on adding the machines, the more and more you are scaling out the machines, yes, the application architecture will also have potential changes. And then you need to require robust network infrastructure and management for of these distributed systems. Since you're connecting multiple machines, the network connectivity has to be robust, and you should be able to manage the distributed system. So this is all about the vertical scaling and the horizontal scaling. And to summarize, vertical scaling is best when you need a quick performance boost, as I have told you as the very first point, by having a simpler application or to face budget constraints in the short term. But on the other hand, the horizontal scaling is the way to grow for applications requiring high availability, redundancy, and the potential to handle significant growth and distributed workloads. So with that, I come to an end, and I believe this video will be very useful to you. So please do subscribe to our channel, give a thumbs up, like, share the video with your friends, and share your comments and the questions in the feedback section. Until I meet you in the next video, it's bye bye from Vasan Shanmugam and your favorite Little Star YouTube channel. Bye bye.